Welcome guys, I am Rajesh Chakraborty. Welcome to my channel, and this is my first video, and I have made this video for the students who are starting in engineering first year. In this video I have discussed about only the nodes analysis. You can see here node analysis. It is a very important topic for the first year engineering students, basically for them who are starting in ECE or electrical engineering branch. So I'm going to show you how you can easily find the voltage across any resistor or any complex circuit. You can find it easily. There is nothing very important to see the what is the direction of the current, direction of the battery potential, that is plus or minus. Nothing important. Only you have to apply some rules, first, second and third. You have to remember first, second and third point. I am going to tell you. So you have to remember only 3 points to find the voltage across any resistor or current in any complex circuit. So let's see here. It's a circuit. It's the potential E1. The current flowing through this circuit for only for this loop is I1, and it is dividing in two parts. One in this direction and one is this direction, and it is E2. Okay. This is R1, this is R2, and this is R3. Okay, no problem. Now, you have to find the node. What is a node? What is the definition of a node? I am telling you. When more than two branches are connected in a point, this point is called node. That means in this circuit, the circuit has two nodes, node A and node B. Okay, so this is the first point. For the node analysis, you have to choose a perfect node. So here what is the perfect node here? I am choosing here the perfect node as VA. I am considering is VA and VB. Okay. Now the second point, you have to put the lower node as 0. That means VB equal to 0. Okay. After that, you can take the direction of the current in any way. I am taking here in this way, in this way, in this way. You can take in any way. That doesn't matter. Okay. Now, after that, we have to apply KCL at node A. Which node? A node. So when we are applying KCL at node A, you have to remember that clockwise the direction of the current is positive. I am taking here. And the voltage and the current is dividing in two directions, one in this direction, one in this direction. So if I write that I1 equals to, so from your common sense, it's dividing in two ways, two parts. It's dividing in two parts. So I1, I2 and I3. So this is I2 and this is I3. This is positive, negative, positive, negative. Okay, very good. So I1 equals to I2 plus I3 from Kirchhoff's current law, KCL. From KCL. Okay. Current is dividing in two directions, one in this direction, one in this direction. So if I write that I1 equals to, so from your common sense, it's dividing in two ways, two parts. It's dividing in two parts. So I1, I2 and I3. So this is I2 and this is I3. This is positive, negative, positive, negative. Okay, very good. So I1 equals to I2 plus I3 from Kirchhoff's current law, KCL. From KCL. Okay,